For the past few years, we have been working with Kate Colich and now Rosalind Archer on WiDS events in New Zealand. Kate has also worked on the WiDS Worldwide APAC regional content team, and Rosalind is the moderator for today's WiDS Worldwide Energy and Sustainability panel. Today, though, I'd like to introduce you to Agate Ponder-Sutton. She's the Advanced Analytics Lead at Chorus New Zealand and also a historical fencer. She draws parallels between the training and discipline that's required for sword fighting and data science.
I'm happy to introduce this talk from Agate Ponder-Sutton. Agate is the Advanced Analytics Lead at Chorus. She's put together a truly awesome talk that really is a must-watch, so please enjoy.
Hi, I'm Agate Ponder-Sutton, and I'm going to talk to you about data science and historical sword fencing and the similarities in training and practicing for both. I'm a data scientist who's worked in both academic research and enterprise delivery. I am also a historical fencer. I want to talk to you today about the motivation to learn to be better and levels of mastery. And my argument to you is going to be that there are important things that we can learn from historical fencing and the training for that that can be applied to data science. All right, I am defining mastery here as a learned skill, and a path to get there is striving to be better than you were yesterday. Before we get going, I wanted to say just how pleased I am to be involved with women in data science in Auckland. I am so happy to be invited back this year. I spoke last year and I was on the panel the year before that, and it is such a pleasure, and I am so proud to be part of this. Okay, let's get started. All right, this is my overview of historical fencing. It is not only the stuff that you see on the Olympics. My own sword weighs about 2 kilos. Historical fencing can be as rigorous as you want it to be. There is space for whatever you want out of it, just like for data science. There's space for whatever you want to get out of data science. All right, so one, I am talking about sword fighting when I talk about fencing. This definition covers many schools, and I'm using a broad modern definition of sword fighting. Historical fencing is about having a single historical text or a multiple historical text that you refer to and get your methods from. Now, scholars will translate and theorize about those methods. So we don't always have all the right answers. Just like data science, it is about trying to do the best that you can with what you're given. All right, so one practitioner is Guy Windsor, and his main historic focus is Fiore dei Liberi. He's an Italian swordmaster of the late 14th century. And I'm going to be referencing Guy Windsor's book, The Medieval Longsword, quite broadly throughout this talk. All right, couple more things before I carry on. All right, fencing is like playing tag with swords. Sometimes it's generally two people. Swords are generally not sharp, but they can be. The armor changes. All of these things are wildly different. But the important thing to remember here is that it's often between two people, and generally there's swords involved. All right, so the last note I have is that data science and historic fencing have a large proportion of white male practitioners. And until a couple years ago, it was fairly common for book on either data science or historical fencing to assume that their audience was male as default. Now, currently, there are in both fields movements towards diversity and inclusion, of which this conference is one movement towards diversity and inclusion. And so things are getting better. So let's carry on, shall we? All right. So data science is a field that contains multitudes, and those multitudes can cause overwhelm. One of the major ones is the variety of choice. There's so much to learn in data science. And from fencing, we know that the place to start is the foundation. And the foundation in data science is statistics and error measurements, and learning the theories behind the algorithms that we use. So for historical fencing, the foundations are balance, distance, and posture. So you can learn without having started with these foundations. However, it becomes harder to learn the entire discipline and be excellent at it if you don't have those pieces. Another major source for overwhelm is my second point on this slide. It is the fact that it is common for stakeholders, your clients, or your other people who want things from a data scientist to think that your keyboard is a magic wand. Now, we know that data science is dictated by the data. And like all things, it's going to take a lot of work, or it's going to take at least some amount of work. So part of knowing your level of mastery is your ability to communicate this back to your client, your stakeholder, or the other people you're writing a paper with. Break things down to smaller words. One of the things that is recommended from that you can take from fencing for this is that if you break a concept down into smaller pieces, it's much easier to explain. So you can use that in discussing a higher level algorithm with your non-data science people by breaking it down into smaller pieces. All right. Just work with what you can. Sometimes there are things that are unknown, and you see that reflected in historical fencing as well. Just walk your client through as much as you can so they can be sure of your methods. All right, it is easy to feel overwhelmed. And there are some things I want you to keep in the front of your mind as I say this. All right, so my point here says don't panic, but it is important to know that panicking can mean that you understand the importance of what you're doing. It can mean that it's a very big deal. And part of mastery is understanding the importance of what you're doing. So to be honest, I still panic. And when I do, I breathe and carry on or try again. And I am still learning, and so is everyone in data science and in historical fencing. My second point here is about competence and ownership. And by these, I mean not only knowing what method you're going to use, but why you would use that method, or why not to use that method in any given place. So you don't have to have everything right now. You can do very much. You don't have to start with a heap. You can have a little bit and do great things in data science. And equally, you can do great things with just a little bit in historical sword fighting. All right. And the last point is about allowing yourself to become comfortable with machine learning and other advanced methods. Machine learning and deep learning and all of those really scary sounding words, they're just tools. And when you are comfortable with a tool, when you're comfortable with a sword, you're going to move better, you're going to do better work, and you're going to be able to do more things. And so if you become comfortable with machine learning and advanced methods, you're going to be able to do your best work then. All right, let me add some more context for you. I became closer friends with Guy Windsor while talking in between workshops. He told me he just started reading Invisible Women, Data Bias in World Designed for Men by Caroline Criado Perez. And if you haven't read this, go read this. It's so good. He was talking about how much he was enjoying being halfway through this book. And I had finished it. And when I started to discuss it near him and a bunch of friends, one of the people present, without malice or bad intent, effectively told me to stop talking so Guy could finish explaining the book that was not in his field, that he hadn't finished reading. And that is actually the point that Perez is making in her book that Guy was reading. And so Perez says, the solution to the sex and gender data gap is clear. We have to close the female representation gap. When women are involved in decision-making, in research, in knowledge production, women do not get forgotten. So not only did Guy correct that person at that particular time, but afterwards he reached out to me for my feedback and guidance on an article about female representation and its effects in the field of historical fencing. In this article, Guy mentions his most popular book, Medieval Longsword, which, if you will notice this sword in the slide we are looking at, this is a rapier. This is my sword. It only weighs 2 kilos. A longsword is a much different sword, but I have to tell you, so I read that this was his most popular book, and I thought to myself, well, maybe I should read that. I read this book, and it's so good. Especially there's 2 chapters in the beginning that talk about how to train, why to train, and how to get yourself motivated, and how to get yourself unstuck if you do get stuck with a project. So much of this can translate into data science. And sprezzatura, the word that we see here, is from the medieval longsword. And I think this word is beautiful. And let me tell you why this word is even more than beautiful. So it describes the calm and confidence in trusting the depth of your own skill. It is both Zen and Swagger. It is the ownership of your own levels of mastery without pretense or ego. So I found this word through fencing, but I believe that it applies deeply to data science. And it's the mindset I'm going to ask you to cultivate. So I want to acknowledge that the quote in the screen here is a nearly impossible task. All right, so let me translate this into data science for you. So the quote says, in fencing, sprezzatura can only be accomplished if the clean, accurate technique flows effortlessly from your perfect, graceful structure, putting you in exactly the right place at the right time to effortlessly overcome your opponent in an aesthetically pleasing way. All right, so this is the equivalent of getting exactly the right data so that you know exactly the right biases and you've accounted for all of them. You've chosen exactly the right model. Your errors look amazing and you're really sure that you haven't overfit anything anywhere. Everything has come together. All of your experience has led you to be in the perfect place to make exactly the right model at exactly the right time. And it's beautiful and useful to your client or stakeholder. So you can see that once I've translated this to data science, this is a very tall ask. So I feel like it's a great way to express what we are aiming to do, where we're going with data science. And in our case, our opponent is the problem at hand or the project you're working on. All right, notes for the fight. These are my notes to take with you to keep close to yourself in times of working on data where it might be a little bit stressful. All right, the data is always awful. I've never met a data set in the real world that wasn't. Things are gonna go wrong, like real wrong. Have backup plans, it's okay. Breathe, believe in yourself and your experience. You have this, and if you don't, you can build to have this. Write yourself a checklist. If they can lift 747s off a runway with a checklist, it will help. It can also help you steer your historical fencing project or your data project. I always have a checklist, and Guy tells me he has one also. All right, first and foremost, let us talk about the data science projects I see most often, and I have seen for the longest amount of time. They are based in statistical experimentation. They are a one-off or something that doesn't need to be run that often, or something that needs to be a report to go to, say, a publication or a trial. These are these are the bread and butter of data scientists and have been for years. You can use them in academia, you can use them in business to get more funding. They start with getting the data and cleaning and exploring it. And then working out what needs to be modeled. What are the families of models that can be used with this particular set of data? What is your subject matter expert? That's what SME stands for. What does your subject matter experts want? What do they say about this data? What does your business, your client, your stakeholder, the other people who are publishing the paper with you, what do they need? All right, once you know all those things, you can move your model from draft models to final models and to insights. And then you need to go back and write up and present those insights. It's very important that this doesn't end with the model. This ends with finding out if you did it right, talking with the people who asked for it in the first place, and finishing the report in whatever format it needs to be. So it is important so these are publications, inquiries into data sets, and they can prove important or life-saving pieces of information. This style is not lesser, and even though it is older. All right, so the checklist that I would use to run the previous project looks like this. And the first question I would start with is, are you answering the right question? Depending on what your audience, stakeholder, client want is what your question and what your data you have, that's going to really shape the questions that you can answer. Is everything divided into a small enough piece? Are you capturing everything you need to capture? Here I've got subject matter expert written out. So what do they tell you? It's really important that if you're not the person who started that data set, if you don't know everything about it, you need to check in with the people who do. So what is your data like? Are all of these things representative? What do the descriptive statistics look like? What kind of skew do you have? In general, there's always a skew, and it's about how big it is and how much it affects you. And what is the behavior that you're trying to build an answer for or a model for? What does that remind you of? Because that can give you a sort of a step into what kind of algorithm you can use. All right, so if you wanted a more advanced or implementation checklist, so you would like to take this model that you've written and then you'd like to be able to put it in production, this is the checklist you would use for that. All right, and you'd start with simplicity and reproducibility. What are the things that you're going to do here in order to help both of those things happen? So the models don't have to be epic. The algorithm doesn't have to be epic, but the insights and the pieces that we can gain from your work do need to be epic. All right, are you going to go with explainable models or verified outputs? Are you going to do a little bit of both? How are you going to be able to say this, like what is the measure that you're going to use to say this model is fine and this is the error measurement I'm using? All right, what kind of regular updates and retraining are you going to do? How often is this going to happen? How is this going to work? Do you need continuous monitoring? Is the model going to be plumbed into production? Is this a really giant one-off? So I have done, once upon a time, a very, very large multi-terabyte project that was a one-off, maybe a two-off. But that needed many of these things. That needed simplicity and reproducibility. So if they ever need to run it again, it needed to be an explainable model. It needed to be able to have regular updates if it needed them, or be able to have them done. So these are why I'm asking these questions. All right. So this advanced implementation model checklist would run this kind of model. So this is when you've taken your machine learning model and you've then put it in production. And these are the steps that I use to prep this kind of project. So if we start here with preparing the data, because that is common to all data science projects. So you prepare the data, you then choose the libraries, which is really important because you're going to be including those dependencies in the container later. You then do your model development and you take and do distributed training, generally because your data is so large and that you want to be able to say, we've done distributed training, you've used multiple instances of this model, and you've trained it in many places, many ways and many places. All right, then you do your model testing. And then you build, once all of those pieces are done and your boxes are ticked and you've got the answers and the error measurements that you want, and everything looks good, then you build an image of that final model and you deploy it. And the way that you deploy it is by putting that model, well, one of the ways, there's always more, there's always more. One of the ways that you can deploy it is by putting that model image and all of its dependencies in a container to run. And then you can schedule and monitor that, and then the results and the monitoring can be sent to the system of record, and on the way, they can be tested to flag the need for retraining. Because data drift is a really big deal with this kind of model. And by data drift, I mean, so you started with one distribution, and over time, your population is going to change, most likely. Like it's very rare for a population or an outcome to not change if you're also affecting it with a model. So one of the things to do is make sure that that's what I mean by continuous testing, is that you're beginning to test and monitor for that need for retraining. So this kind of model has only arrived to smaller players than, say, Netflix in the last couple of years, the last 4, I'd say. And it has been a change, and I've only seen it in enterprise so far, but I can imagine it happening in academia as well. That you see this instead of the detailed report or model that runs on your desktop. So this was a large team effort, and the team I run now does very similar things. And the advanced analytics lead for Chorus, and I run a small team I'm very proud of, and we do this kind of work. We also do the smaller sets of models and pieces of insight, but this is the main piece that we do. All right, our discipline is always changing. And so Guy has a great quote for this as well. And as the research develops our idea of how things should be done, so we have to change our physical practice. And for data science, our physical practice is what we know, it's the models we use, it's the methods that we're familiar with, it's all of the things that it takes rather a lot of work to keep current with. And one of the ways that you can do this is to, okay, so read and check in with your data science colleagues, make friends in the field. You can pick up more methods by studying. You want to make your practice continuous, because data science is so broad. Things are going to shift, and so instead of being behind the 8 ball and being, oh my gosh, things changed, I have to go upskill completely. If you're just in constant awareness of that, you can sort of feel the change, or you can see the changes coming in the overall field and be with them as change happens. So like I said, the change I have seen that is most obvious is the incorporation of machine learning in enterprise on a daily basis, and the productionization of models, and which is extremely exciting. All right. What are the questions that will help you do your data science? So practice can always help, and making your own checklists can help. I'm happy for you to take my checklists if you feel like that would be helpful. And I'm also happy for you to write your own. So I want to thank you, and I want to thank Women in Data Science so much for allowing me to be part of this conference. And look me up on LinkedIn. I'm in several other places as well, but LinkedIn is probably the best place to find me right now. So thank you so much. Yeah, actually come hit me up on LinkedIn and ask me questions. That sounds like a great plan.